MCT4C, this is our lesson 8, again the second half, and the first half recorded successfully, so I'm very happy. All right, second and last example for you. A ball's height, h in meters, t seconds after being thrown off a cliff, is given by the function h at t equals minus 5t squared plus 15t plus 50. We know that this equation is a quadratic because the degree is 2, and it's negative because that initial value, the leading coefficient, is negative 5. Part A asks us to determine the ball's initial height. In math, we are asking you for the y-intercept. We know that the y-intercept is always the standalone number at the end of a polynomial expression. So the initial height for the y-intercept is 50 meters. Part B asks us to use technology to determine the maximum height of the ball and when it occurs. Since we have a quadratic, we know that we are looking for the vertex, the only max that we're going to have. So we need to type this equation into the graphing calculator. And look for the maximum value. So under the y equals button, we want to put that function. It is, well, we have to stick with y equals negative 5. Be careful, the negative is a white button at the bottom, not the subtract. Negative 5. We need to use x instead of t. X squared, there is a square button, specifically plus 15x for the calculator, plus 50. We're going to hit graph, and we're not going to see it very clearly. That's because our domain and range don't make sense under the default values, which are minus 10 to 10. And in our case, we'd already changed them to 0 to 10 and 0 to 5. So let's think about our domain and range reasonably. The domain, or the x values, is our time for this particular problem. Time would not be negative. It's in seconds, so a 0 minimum for the domain makes sense. 10 seconds is the maximum. Sounds reasonable. Certainly makes sense as far as a ball in the air goes. But our range might be different. Our minimum value for our range we put in is 0. It does not make sense to have a negative height, so that is fine. The maximum, however, should be greater than 50. If we've thrown it off a cliff at an initial height of 50, it would be higher than that before it begins to fall. We're assuming we're throwing it upwards a little bit. So I'm going to make the other end of my range 100. And we'll see if we can see it a little bit better when we hit graph. Beautiful. So for part B, we have been asked to determine the maximum height. So we can see that vertex at the top of the parabola. So we're looking for that value. And we are going to use our graphing calculator to find max. So we need to go to calc, which is up above the trace button at the top, second function, calc. We want maximum, which is option 4. In order to tell the calculator exactly where to look, because it doesn't know what kind of a function you're looking at, you need to do the left, right, enter business. So I'm going to scroll to the left of that maximum value. There we are. Hit enter. Scroll a bit to the right, and you can see at the top that it's marked the range that it's to look for. Hit enter again. And there is our maximum value. If we were to write that vertex as a point, it would be 1.5, approximately 61.25. So now to translate that to the word problem, it says find the maximum height of the ball and when it occurs. Part B, the maximum height of the ball is 61.25 meters, and it occurs when t equals 1.5 seconds or after 1.5 seconds. Both of those pieces of information came from the vertex. Part C says determine the average speed of the ball during the first second after it was thrown. So if we want average speed, seems like a trick question. But we know that the height at 0 seconds was 50. Forgive my succinct writing there, but the point 050 indicates we had a height of 50 at 0 seconds. If I could find how high I was at 1 second, I would be able to calculate my speed. Speed is how far you went and how long it took you to go that far. So I am going to find specifically the value of the function when x equals 1. So part C, I want to find the point when x equals 1 so that I can calculate the speed. All right. We go to the calc button. The first option is value. And I can type any specific value for x, and it will give me the answer for y. So at 1 second exactly, it was 60 meters in the air. That means it had traveled a distance of 10 meters in that 1 second. The speed was 10 meters per second. Not lastly, D, use technology to determine when the ball strikes the ground. So we are looking for an x-intercept. We want to know when that occurs. So to find an x-intercept, I do calc again. Remember, they call them zeros. 0 is your second option. I have to take my cursor to the left of that x-intercept. I'm going to go a little closer to the curve. And then to the right, markers, enter, and I will have my x-intercept. And you know it's an x-intercept because the y value is 0. So we have an x-intercept of 50. And when the ball strikes the ground, D, the ball strikes the ground. After 5 seconds, or at 5 seconds. Lastly, what was the ball's height 1 second before hitting the ground? So specifically for E, I would like to know what is the height, and I like to use shortened math short forms, height at 4 seconds. So that's what I want to figure out. We're going to do it by hand in a second, but let's let the calculator do a check for our answer. I want the value. So I want calc, number 1, and I want to put in the value 4 seconds. The height was 30. The height's getting tired. And the time was 4 seconds. If we had wanted to do this by hand instead, didn't have a graphing calculator at a party and we wanted to figure this out, we would just put 4s into the equation. So our equation minus 5t squared plus 15t. So we put a 4 there. And for that x as well. And we just need to do that calculation. So careful with order of operations. 4 squared is 16. I need to do the power first. And then we're going to do multiplication. Negative 5 times 16 is 80. And our final answer should also be 30. So you can do it with a graphing calculator, you can do it by hand. Some of these other calculations, our goal will be to do them by hand as well. We have our function, if we could write our function in factored form, we would have known a lot more than we thought we did. I see a common factor of -5. So I'm going to take that greatest common factor out. You can see what we're going to be doing tomorrow. I need to change the signs in the bracket because I took a negative factor out. So when I've taken a greatest common factor of -5 out, that is what I have. Nope, I made a boo-boo. Did you catch it? That should be a 3. Next line. I see a simple trinomial. Again, don't know who called them simple. Where I would put up 2 sets of brackets with the letter T at the beginning of each. I need to find 2 numbers to put in the end of these brackets. Those 2 numbers need to multiply to -10 and add to -3. So my 2 numbers are -5 and +2. So I have fully factored, there we go, our function. And that tells me right there that one of the x-intercepts is 5. The other one is -2. So my one t-intercept right there is 5. We discovered that when we used the calculator. The other one is -2, but it's not within the domain of the problem. So if we had factored it, we could have answered part D without using a graphing calculator. I have some questions for you. Problems on page 99, 1 to 12. If you choose any 6, making sure you cover quadratic, cubic, and quartic, you should be good to go.